Hi, my name is Kiran Baburaj, and today we will be diving into one of the most fundamental data structures in computer science, that is, tree. We will break down what trees are and why they are so important in the programming and real world applications. Let's start by visualizing a tree. At the top, we have a root node. This is where everything begins. From the root, we branch out to child nodes. These are connected to roots by edges, forming the first level of the tree. And the tree grows further. Each level represents a deeper layer of hierarchy. Now let's break down some of the key terms used in tree. The first one is parent, a node with children. Then the child, a node connected to the parent. Next the leaf, a node with no children. Level, the distance from the root. Trees have some unique properties that makes them powerful. 1. Unique path between any two nodes. 2. No cycles are allowed. 3. N nodes have n-1 edges. And finally, height determines the efficiency. Now further moving on to the real world applications. We know that trees are not just theoretical. They are used everywhere. First one is the file system. We have the organizing the files and folders in tree-like structures. Next is family trees, mapping the relations. And the organization charts, structuring the hierarchies. And for database indexing, speeding up the searches, we use the trees. So the general idea about the trees are the hierarchical structure. Trees organize data in different levels. They have the efficient organization. They provide fast access and retrieval. Versatile data structure. They are used in the countless applications. And they are used as foundation for the advanced tree-like structures such as binary trees, AVL trees and more. Further, we delve into different types of trees. Each type has unique properties and use cases. So let's explore one by one. First, the general tree. This is the most basic form of tree structure. Here, nodes can have any number of children. They are used in the file systems and organization charts. There are no ordering between the siblings. The depth can vary between branches. And their examples are directory structure, and they are used for representing the hierarchical data. General trees are perfect for representing the hierarchical relationships like folder structures or organizational charts. Next we have the binary tree. This is more specialized form of tree. And its features are each node has at most 2 children. It's perfect for hierarchical relationships. It can be complete, full or perfect, will be discussed later, and they are efficient for recursive operations. They are used common in compiler design and game AIs. The binary trees are widely used in algorithms and data processing due to their simplicity and efficiency. We will be further discussing it in detail. Now let's look at the binary search tree. This is a binary tree with a special ordering property. Here, what makes it powerful is that it has the ordering property of left child less than parent less than right child. It's efficient for searching and sorting. It has an average search time of order of log n, and it supports dynamic data updates in order traversal, giving the sorted data, and used in database indexing systems. Finally, we have the AVL tree. It's a self-balancing binary search tree. That is, the height difference less than or equal to 1 between the subtrees, that is left and right subtree. It guarantees a order of log n operations. It auto rebalances after insertions or deletions and prevents the worst case scenarios. It's used in memory management systems. AVL tree ensures optimal performance by maintaining balance, making them the perfect choice for dynamic datasets. So each type of tree has its own specific use cases. We have to choose the right tree based on the requirements to unlock its full potential. Thanks for watching. If you found this video helpful, don't forget to like, share and subscribe. Happy coding! and see you in the next video.